Trapezoidal rule is one of the numerical integration methods. In this video, I would like to talk about how to derive the trapezoidal rule. Since trapezoidal rule is based on the left sum and right sum, it is necessary to review them first. So I have a table value. The first row is x, and then the second row is the y value. And then I want to find the left sum and right sum using 5 subintervals. So since the maximum is 8, the minimum is 2, to find the delta x is the width of the strip or the width of the rectangle. We take the maximum minus the minimum, 8 minus -2, 10 divided by 5 intervals. So each interval is 2 units long. And then for the left sum, how do you find the left sum using 5 subinterval? You grab the first 5 values, right, from left to right. So we have delta x, which is positive 2, times f of -2, f of 0, f of 2, f of 4, and f of 6. So after you distribute the 2, so the 2 is the base, and then f of -2 is the height of the rectangle. So base times height, you have area of one rectangle. And then the next rectangle, you have the base 2 times the height f of 0. And then the next rectangle, you have base 2 times the height f of 2. So after you add the y values and then multiply by 2, you get the left sum. And then the right sum is you pick the first 5 values from right to left. So from 8 and then all the way to 0. You do not pick the last value. So that will be the delta x2 times f of a, 6, 4, 2, 0. So of course, after you distribute the 2, so 2 times f of a is the height of the first rectangle on the right. 2 times f of 6 is the second rectangle from the right. And then f of 4 times 2 is the third rectangle from the right, so on and so forth. So after you add up all the products, the sum is equals to the area under the graph of f of x using right sum, 5 subintervals. What about midpoint? Midpoint means you take the right and left divided by 2. The answer is no. Midpoint is another method. So for the midpoint rule, this time I have another table for you. I would like to use 4 subintervals. So I will take the maximum, the 9, minus the minimum 1, that equals to 8. 8 divided by 4 subinterval. Delta x is equals to 2. So consider the width of the base or the width of the rectangle. The base is equals to 2 units long. And then since you will be using 4 subintervals, so that means from 1 to 9, I have to cut that into 4 pieces. From 1 to 9, I scale the straight line using purple numbers, and then the width, the 2 units width, I did that using blue. So from 1 to 3, that is the first interval, the width is 2 units. From 3 to 5, the interval is 2 units long. From 5 to 7, the interval is 2 units long. From 7 to 9, the interval is 2 units long. So we have a total of 4 subintervals. And then for the midpoint rule, you don't need to go from right to left or left to right. All you have to do is you take the delta x, you multiply the width. So what is the width? Not the width. What is the height of the first interval? The height of the first interval is f of 2. So f of 2 right here. F of 2. When x is equals to 2, what is y equal to? So the y is the height of the rectangle. And then the next height is f of 4. When x is equals to 4, you have the height of the rectangle. And then the next one is f of x. And then the last one is f of 8. So that's why we have to take the delta x, multiply f of 2, f of 4, 6, and 8. So the sum is equals to the area under the curve of f of x using 4 subintervals from 1 to 9. And then what about trapezoidal rule? The trapezoidal rule, so you learn left sum, right sum, and midpoint sum in the past. Let me add one more to it. The one more is trapezoidal rule. So trapezoidal rule is the average of the left sum and the right sum. So I built another table for you, and I'm going to use this table to derive the trapezoidal rule. So in this table, I have 5 x values, x1, 2, 3, 4, 5, and then for each x, we have a corresponding y value. So f1 for 1, f2 for 2, f3 for 3, so on and so forth. And then I would like to use 4 subintervals. So 4 subinterval, you take the maximum minus minimum, 5 minus 1, and then you divide it by 4 subintervals. So each interval is 1 unit long. Using the left sum, 5. Oh, that is not L5, huh? I make a mistake right here. So that is supposed to be L4 and R4. So L4 and R4. So using left sum, 4 subintervals. So the way we take the y value is we go from left to right. We take the first 4 y value. So 1, 2, 3, 4 from left to right. So that's why we have delta x times the sum of f1, f2, f3, and f4. And then you distribute the x to the f1, 2, 3, 4, and then you have the distribution. And then what about the right sum using 4 subintervals? So that will be from right to left. You take the first 4 y value. So 1, 2, 3, 4. Do not take the last one. From left to right, you don't take the last one. From right to left, you don't take the last one as well. So that's why in right sum 4 subintervals, we have delta x times f5, f4, f3, and f2. And then you distribute the delta x. Okay, so you have delta x multiply each of the height. So the delta x times 5 is the height of the first rectangle from the right. Delta x times f of 4 is the area of the second rectangle from the right, and then delta x times f of 3 is the area of the third rectangle from the right, so on and so forth. Now, I said that the trapezoidal rule is the average of the left sum and right sum. So what is average? Average means you add up 2 sums and then you divide it by 2, right? So you add up 2 sums and then divide it by 2. So what I want you to do is, if you look to all the way on the right, so we have a bunch of delta x times a f value, right? Okay, so why don't you add them and then divide it by 2 for me? So let's do that right now. So the divided by 2, I will just take the 1/2 out. And then when you do the addition, do we agree that only the f of 1 and f of 5 stands alone? The rest of the f, so f2, there are 2 copies of f of 2, right? And 2 copies of f of 3 and 2 copies of f of 4. So the way I want you to do this is, when you add them, so I'm going to write delta x f of 1, and then the last one is delta x f of 5. But look, when you write f of 2, so we have f of 2 plus itself, and then we are going to do 2 times delta x f of 2, because we have 2 copies of that. And then for f of 3, same thing, we have 2 delta x f of 3. And then for f of 4, we have 2 delta x f of 4. Do we have 2 delta x f of 5? No, we only have 1. So the last one is delta x f of 5. All right. And then what else can you do? Can we factor out the delta x? Okay, so we can factor out the delta x, right? So that means I can draw this. So we using trapezoidal rule T, using 5 subinterval, I factor out the delta x and then divide it by 2. The 2 in the denominator comes from the average, right? Divided by 2. And then what is that equal to? That equal to f of 1 plus 2 times f of 2 plus 2, let's make the 2 bigger, 2 times f of 3, and then 2, I want to make the 2 big, 2 f of 4, and then last but not least, f of 5, no 2. So that is how you do the trapezoidal rule. And then what is the sum equal to? I didn't give you the corresponding y value, but in a function f of x, when I give you x is equals to 1, you plug in 1 to the function to get the y value. So getting the y value is not hard, but the purpose of this exercise is try to derive the trapezoidal rule using the table value above. Okay, so let's draw a summary. So let's switch color. I would like to draw a summary right now. So the summary is trapezoidal rule. So trapezoidal rule. So what is trapezoidal rule? Trapezoidal rule is we are doing numerical integration. So let's say we have integral from a to b f of x dx using trapezoidal rule to approximate the sum. So I have t stands for trapezoidal, and then using n subinterval, and then that is equals to, you have to take delta x divided by 2, right? And then for the stuff inside the parenthesis, first you have f of x0. What is x0? x0 is the very first x value, or the very first value in the domain. Because this one x is between x of 0 and x of the last one, we use n, right? Suppose we are using n subinterval, okay? And then the next one, look at the lines above. So other than the first f and the last f, all the f's in the middle has a coefficient 2. So that next one is 2 f of x1, and then plus 2 f of x2, and then plus 2 f of x3, and then if you keep going, 2 of f of x4, and then 2 of f of x5, and then when you go all the way to the last term, then there is no more f. Then there is no more 2. So you only have f of xn. xn stands for the very last y value. And then this is the trapezoidal rule. And then I have to specify that delta x is the maximum x minus the minimum x divided by n subinterval. And then what else? Here is one thing that I would like to call. I would like to call this the coefficient pattern. So coefficient pattern. What's the coefficient pattern? The first one is a 1. The last one is 1, right? So f of 0, there is a 1. F of n, the coefficient is 1. And then for the rest, we have all 2. And dot 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 until you reach to the last one. Okay, so that's how you got the trapezoidal rule, and that is also the end of this video. If you think my instruction is helpful, let me know in the comment below. Like the video, share the video for me, subscribe to my channel. See you all in the next one. Signing out for now.